All right. Good morning. I'm trying to work on welcome to AP Chemistry. I wanted to do an example problem of how to calculate pH. And so I have two examples of this just to make sure that we're on the same page as what we are doing. So a solution at 25 degrees Celsius has a concentration of hydroxide equal to 6.7 times 10 to the negative 5 molarity. What is the pH of this solution? All right, so we know in our understanding of pH that pH equals the negative log of the concentration of hydrogen. That is the definition of pH. Okay, so the P represents the log, and the H represents the concentration of hydrogen. We could also calculate POH, which is negative log of the concentration of OH minus, like that. So we could calculate the POH as well. But in order to get pH, we need to get to the hydrogen concentration and then use our calculator to do this. All right, so that's what we're going to try to do for this example. And so let me work out. There's two ways to solve this problem, and you can do it either way. The first way is knowing what we know about how does the concentration of hydrogen and the concentration of hydroxide work. Well, this is equal to 1 times 10 to the negative 14, which is our equilibrium expression for water. And you should have learned this as well. So we can use that way, or we could use a different way where we say that our pH and our POH equal 14. And this all happens at 25 degrees Celsius. These are two different ways to do it. I'm going to do both of them so you can see how to do them and you can decide. I think doing the pH and the POH way is a little bit easier and straightforward, but you can do either one. So to calculate the pH using this, we know the hydroxide concentration is 6.7. That's what we know, and we can plug it into this formula times 6.7 times 10 to the negative 3. I encourage you to have some work out and try to follow along. Maybe even get ahead as I am working through this. Times 1 times 10 to the negative 14. The only problem with this is that we're having to deal with scientific notation. So be careful with your scientific notation, and you can do that. I'm going to show you a method of doing that on the calculator right here. So and I'm going to use this EE button, 10 to the negative 14. So I'm taking the 1 times 10 to the negative 14. I'm going to divide it by 6.7, and then I'm going to use that EE button, negative 3. If you do that, it works. If you're using times 10 to the value, then you're going to have to put everything in parentheses. But if you use that EE button, you don't have to put everything in parentheses. So hydrogen concentration is 1.49 significant digits times 10 to the negative 12. So there's your hydrogen concentration. To get your pH then, you take the negative log of your hydrogen concentration, like this, and I will do that. So now I am going to take the log of my answer, and I get a negative. So the pH equals a negative times a negative 11.8, 3 significant figures again. And then, or I can cancel out those two things, and our pH is negative 11.8, which is basic. Our pH scales goes from 0 to 14, and that's that. If you notice that our hydrogen concentration was 1.492 times 10 to the negative 12, which is very, very small because of the negative 12. Our hydroxide concentration was 6.7 times 10 to the negative 3, which is more. And so it should be more basic because there's more hydroxide. All right, now I want to show you doing the second way. if we do the second way, we can figure out what our POH is and then use that to figure out that. So our POH equals negative log of our OH minus. Well, our OH minus is what's given. So it's negative log of 6.7 times 10 to the negative 3. So let's do that. We're going to be doing the log of 6.7 times 10 to the negative 3. And that gives us a negative 2.43. But when we take that negative of a negative, it just equals 2.43. And then our pH plus POH is 14. So the POH is 14 minus 2.43. This is an exact 14, so the significant digits are, you don't have to worry about the significant digits of that. So 14 minus 2.43 equals 11.57 or 11.6 with those. I am not sure, must have been my rounding, why these aren't the exact same, but they should be the exact same. So two different ways of getting pH of a solution. Now I want to do one more example here. Hopefully this will make sense here. The second example is a sample of freshly pressed apple juice has a pOH of 10.24. Calculate the concentration of H+. So it's kind of the reverse way, and I think that's an important thing to be able to figure out. All right, how would you do this? Think about it. We need H+. We know pOH. There's two ways to do it. I am going to show you what I think is the easier way. Which way would you use? All right, so I am going to use our pH plus pOH equals 14. Right there. We have our pOH, so pH is going to be very relatively simple to find. Is 14 minus 10.24. So 14 minus 10.24 is 3.76. That's our pH. And then we need to get hydrogen concentration. So pH equals negative log of 3.76. This is where we get a little bit, no, our pH is 3.76. Everybody makes mistakes, so yes, they do. All right, it's the negative log of our hydrogen concentration. Our pH is 3.76. Negative log of H+. So how do we get rid of logs? Do you remember your math? So the opposite of a log is 10 raised to the power of something. And there is a function on that. So I'm going to put this, I'm going to switch sides and get rid of the negative on that side. So it's the log of 10 of H+ equals negative 3.76. And then we are going to raise both of these. This is the opposite of a log. I'm going to raise both of these to the power of 10, 10 times that. 10 to the log cancels out. And so that is our H+. And then we have 10 raised to the power of negative 6.3. And there is the function. The second log is is the function of that. Negative 3.76 is what we're raising it to. And that, oh, I did a problem. So 10 to the power of negative, I did minus 3.76 to the negative 3.76 is 1.74 times 10 to the negative 4 molarity. That is what the concentration of that is using that. So calculating pH, need to get that straight really to move on to all these other lessons. Thank you.